Hey everyone, welcome to my channel. In this video, I built a VTOL Tricopter, and that is a vertical takeoff and landing aircraft with 3 rotters. It flies like a plane, lands like a drone, and really crash like both. So yeah, you could call it a multi-crashing capable aircraft. I didn't design all the part by myself, but I've been learning how to assemble it step by step, from 3D printed parts to electronic, all the way to real flight. Along the way, there were some simulator crash, a lot of them, and some real crashed, soldering burns, and some surprisingly funny English from my teacher, which I will show you at the end of the video. But in the end, we got it flying. So let's jump in, starting with unboxing. The package has just arrived. So we first got our 3D printed parts in the box, and we also got our ESCs, the rotters, and the XT60 ports in the back. And here's a diagram to show all of our material, including those carbon fiber rods, those 6 servos, a GPS modules, airspeed sensor, batteries, and much more. So it is now the time to assemble our 3D printed parts. This is one of the rotor, and those are the 3D printed part that I finished assembling. We put one of the motor at the back of the plane to give it the force to go upward. Those wires need to connect to the battery board, and some need to connect to the flight control. It is hard to explain all the detail of how I assemble it in only a limited amount of time, but I will try my best to use less than 2 minutes to explain how I assemble it. Time started now. I start by getting all the Wen series components. Then I begin the pre-assemble by connecting the 3D printed parts using carbon fiber rods. Once everything is aligned correctly, I glue the parts together using a 416 adhesive glue. This ensures a strong and stable wind structure for future flights. Next, I install 8 M3 heat set insert nuts using a soldering iron. Their position are marked clearly with a blue marker for easy placement. After that, I put the motor and the servo onto the wind, making sure the wires are properly routed and secured. Finally, I installed the ESC, which is the electric speed controller, which connects the motor to the autopilot system. Next up, the body 3 components. I followed the diagram and carefully glued the fuselage piece together. One important thing to know, the 2 set of caps are removable, so we don't glue them directly to the main body. Instead, we install 4 6x4mm magnet into the hat caps and hat 1, secure them with glue. Small design choices like this, using magnets instead of permanent glue, really make a big difference when people are building something modular. Inside the fuselage, we also need to leave space for several components: the airspeed sensor, battery, transmitter, and GPS module. This gap here is reserved for either a record camera or a live FPV camera. And in body 1, we also need rooms for the autopilot, main circuit board, and sometimes even an onboard computer, depends on your setup. Last, we move on to the tail series components. I start by gluing tail 1 and tail 2 and one elevator together, then connected the full tail section using carbon fiber rods. I also double checked the rudder and elevator before final assemble since they are moving parts, so they shouldn't be glued to the frame. After that, I installed 2 servos into the tail, one to control the elevator and the other to control the rudder. Everything's aligned and moving smoothly, so it's ready for the final assemble, which is... And yes, it is a gorgeous part, the soldering assembled. battery and the flight control. Airspeed sensor is positioned on the head of the plane. This is the drone body after we assemble it and put the soldering parts in it. However, we couldn't put the wing directly to it due to a mistake I made. So I decided to make a new pair of wings and then put it directly on the plane. Servos are connected to the elevator and the rudder by using a thin iron rod. Then we are going to charge over our battery to prepare for tomorrow's flying test. After setting up the correct parameter, including the correct voltage and the electricity current, it's time for charging. Have you wondered why it is charging so fast? The reason is not we put a controlled nuclear fusion in the battery or in the charger. The reason is I accelerate the speed to 1,000 times when I edit it. By the way, please check carefully for your transmitter battery health and avoid making the same mistake with me. The lithium battery in my transmitter is bulging. If this happened in a real flying experience, my plane gonna crash to debris. And lucky to me, since I decided to practice on simulator tonight and I find this mistake I made. After assembling the planes and doing preparations, it is a time for simulator. And you might wonder, what is a simulator? And a simulator is technically a simulator. Actually, a simulator allows you to fly a drones or planes on your laptop to avoid crashing the real things. And it is really useful for practice flying. And seriously, things are not going smoothly. Since I fly FPV drones before but not flying plane models, and the controlling system is totally different. So you'll basically see crashing, and crashing. Crashing on the fence, crashing on the house. Whoa, that was unexpected. And also circling in the water. One time it was almost landing successfully on the runway. However, things are not that easy. And it crashed on the fence. Then, same spot, same mistake, same time, crashing on the fence again. After crashing so many times, I think it's time for me to practice, because I don't want tomorrow to be a regret. After practicing 2 hours and some crash though, I finally know how to fly like an expert. Glide on the water, both the right wing and the left wing to control altitude. And also flying backward. And flying backward close to the ground. And even crashing a jet. Flying a jet without wind. And seriously, really flying it. make it up to the air. And here's a brief introduction of how to use a transmitter to control a plane. The transmitter sends out signal to the plane, and the receiver in the plane give out the signal to the flight control. The flight control then connected the servo, both on the rudder, elevator, and aileron, in order to change yaw, pitch, and roll, which can control the direction and move up or down to help a plane. Some planes have a spoiler, which can change lift, drag, and roll. It is late at night, so I decided to go to sleep. Having a good sleep can also help me to focus on tomorrow's flight. By the way, this isn't my home, because I live in Beijing, and there's a no-fly zone there. It means we cannot fly any kind of drones, aircraft, because it might give negative impact to citizens who live there, and it might cause damage and it will be very dangerous. So we drive about 2 hours to here in order to fly this plane. And passion might be the only things that will not be tedious even you're tired. And here one of my tutors is telling me the arrangement of the plane, including how it can fly like a drone and fly like a plane, and how it can use 3 rotters to fly. I know some of you might don't know Mandarin and some of you might know, but still, I'm here to serve as a gold medal translator. So this model is a Y-Street tow model plane, and it can change to a plane by using its servo and make the rudder face directly to the front and generate force to propel it forward. However, there might be a problem, and this is because a normal drone it got 4 rotters. So all of the force that will lead the drone to rotate can counteract, and this is why it can be so stable. However, this drone only got 3 rotters. How can it be counteract the actual force that will help it rotate to the right or to the left? And the answer is, one of the rotor will lean a little bit forward to generate more force to rotate in the opposite direction. And this is why it can counteract the actual force. After assembling, soldering, learning the arrangement flying simulator, put all the components in it, it is finally the time for flying the real thing. You can see the high voltage cable at our back can be a barrier to fly our plane, so we decided to only fly our plane in front of us and try to avoid flying back of us. By the way, those are crops, so we walk very careful to avoid step on it. Before flying, we check the plane very carefully again. Even screws that are not tightened can cause great damage. One of my tutor in front of laptop will tell me the parameter, the speed, and the attitude of the plane. And the other tutor can give me suggestion and tip for controlling.
这个应该是民用的，是不是？军用的好像就不会干扰，但是军用的那啥。
是那个频段跟卫星收。
录屏了吧？
录了。
OK。
哎，为什么没有往后退了？之
前就调好了，不会往后退了。
我也打杆了，我
你打了一点点杆，你就原地给的话，它也不会往后退。
This is the first flying test. It is the only purpose to see how does the plane work when it is a drone mode, and it will not go too fast.
在后面看。
一般飞它。
就是那个客机，像客机降落了。
我录着呢，没事。
倒退的。
最前进的。
最前进，我不敢倒退。
And this is the second flight where we decided to convert to the plane mode. However, I fly out to the radius that we set up, and it is out of control because I cannot see it. Lucky to me, the flight control saved me, saved my plane. I fly to the point that we set up automatically, and after I convert to the drone, it lands safely. However, we only got one piece of battery left, means I can only fly one round left. There's two decisions. One is to fly plane mode again, which is much more challenging. One is to just go back to home and you can save your plane. My decision was to challenge. And there you have it, a VTOL Tricopter that can actually fly. Well, most of the time. Thank you for watching my video. If you like this video and enjoy watching my crash, hit that like button. And I will see you next crash. Next flight.
Hello.
Oh, yeah.